All right, so lesson 2-5 is comparing proportional relationships. And that is a lot of big math speak for just when you compare something, right? You're just comparing two things. Proportional relationships are just fractions. So 1/4 is a proportional relationship. And if I asked you to compare 1/3 and 1/4, then you're comparing proportional relationships. So it really is pretty simple. And a proportional relationship is a division problem because it's a fraction, and fractions are division problems. So as long as you know how to divide, you're good to go. Okay, so this section really isn't too terribly bad. So I asked you a minute ago, I asked you if I was going on a drive, right? And I drove 80 miles and it took me 2 hours. And I asked you guys what my speed was, and you guys told me I was going 40 miles an hour. Okay. You got that because this was my distance, right? My distance over my time. That's how you figure speed. And what I needed is I needed per 1 hour, not 2 hours. So I needed it to be over 1, right? And so I divided by 2 and divided by 2, or you did because you all told me the answer. And you got 40 over 1, which was 40 miles per hour. Okay. And that's all we're really going to be doing today. This right here is called, and it's a big math word, it's called the constant of proportionality. It's a big word. Constant just means doesn't change. So that means that the entire drive, I didn't speed up and slow down and speed up and slow down. I just went 40 miles an hour the whole time. I set my cruise control and I never let up. Okay. That's what constant means. And proportionality just means my distance divided by my time. So when you hear constant of proportionality, like don't let that, because it's big mathy words, don't let that make it harder than it is. Constant just means it doesn't change. Proportionality is just my distance divided by my time. Okay. So let's look at this apple orchard versus the fruit orchard. So if we wanted to compare these two, right now we can't really compare them because there's too much information that's not alike. So I'm gonna redo my proportions or rewrite my proportions so that they are comparable. So if you go to Annie's apple orchard, she charges for 20 pounds, she charges $7.25. And at Franklin's fruit orchard, he charges for 12 pounds, he charges $5. And you want to know, where's the better deal? Where should you go get your apples that you're going to pay, if considering, or if you just assume that quality is the exact same, where are you going to want to go to buy your apples? So we need to find the constant of proportionality, or we need to get them both over 1, right? We need to know how much per ounce. I know that Annie's charges $7.25 for 20 ounces, but I need to know what she charges for 1 ounce. So we do just like we did with my speed. We put the total amount, the cost, over the ounces. And since I don't care about what it is for 20 ounces, I want to know what it is for 1 ounce. I just need to change my proportion. Well, in order to get the bottom equal to 1, you would divide by 20. And so that means you would divide the top by 20, or you would reduce your proportion. You would take $7.25, so 7.25, and you would divide by 20, and you would, and I'll round, it's 0.3625. You would get 0.36. And so what that means is at Annie's orchard, we're going to pay $0.36 per what? Per pound, right? Okay, so that's the information for Annie's. Now we need to do the same thing for Franklin's. We know that Franklin charges $5 for 12 ounces or 12 pounds, but we want to know what he charges for 1 pound. So again, we need to convert our fraction to where it has a 1 in the denominator, or 1 pound. So we're going to divide by 12, right? And when we take $5 and we divide that by 12, we get 0.416. So I'll round that to 0.42. And what that means is at Franklin's stand, we're going to pay $0.42 per pound. So where are you going to go shopping for your apples? What do you guys think? Somebody tell me. Yeah, we're going to go to Annie's because Annie only charges 36 cents per pound, and Franklin charges 42 cents per pound. So that is basically the whole kind of unit in a very small nutshell. We'll talk about other ways you can be given this information, but that's what we're going to be doing. We're going to be comparing two things by putting them both in a fraction and then getting both of them reduced to that constant of proportionality, or getting them reduced basically till the denominator is a 1, and that way you can compare both items, okay? All right, so we're going to be given the information in 3 different ways. Okay, and we're actually not comparing these two. These are just different ways that you can be given information. Okay, so we're actually not comparing these exact 2 things yet. So first of all, you can be given the information in a table. And when you're given the information in a table, I do want you to add this to your notes. In a table, the top is always the X and the bottom is always the Y. Okay. And if the table is set up over like this, the X is always on the left and the Y is always on the right. So just kind of so you understand how math tables or the information is usually delivered to you. If fits in a table, the X is on top. Okay. And we've already talked, this is distance and time. So this is a speed question. And we've already talked about to find speed. Okay, we've already said this. So if you've already written it, you don't need to write it again. Speed is distance divided by time. So if we want to find the speed of this Cessna along the way, each one of these, and we don't really see it this way because it's in a table, and you don't have to write this. I'm going to erase this here in a second. This right here is an ordered pair, right? It's an X and a Y value. And if I wanted to, I could write it like this, right? It's an X and a Y. It's a coordinate pair. I could plot this on a graph if I needed to. Now, we're not doing that today, but that's what this data is. It's information. It's ordered pairs. It's an X and a Y that you could use to graph if you needed to. But we're not going to do that today. Today, we want to find the speed, okay? Because we want to compare or find the constant of proportionality. So the way you do that is distance divided by time. Now you have to be careful because your fraction is distance over time. Your Y is always on top. In the table, the Y is on bottom. So you really have to be careful not to get your fraction messed up. But this equals 8. And if we go along the line and we set every single one of these coordinate points up as a fraction or as a proportion, if we take 120 divided by 15, we're going to get 8. If we take 240 divided by 30, we're going to get 8. No surprise. If we take 360 divided by 45, we're going to get 8. And then 480 divided by 60, and again, we get 8. So that means that the Cessna is traveling at a constant speed of 8 what? You got to look at your labels to know. It's 8 kilometers per minute. You got to really look at your labels to know is it miles per hour? Is it kilometers per minute? Is it pounds per second? You always have to look to your labels in each individual problem to know what the story is telling you. Okay. So the constant of proportionality for the Cessna is 8. Okay. 8 kilometers per minute. All right. Now, sometimes you'll be given the information as a graph, and you really don't do it any different. It is still distance over time, or you can also think of it as Y over X, because not every graph or story problem is going to be a distance one. And I think our next example is one like that. It's not distance. It could be like our first one, the apple orchard. It could be cost over pounds. So it's not always going to be distance over time, but distance over time is the same as, and it will always be Y divided by X. Okay. So you've got to know your coordinate, your axes and the names of them. So obviously you guys know this, but this is your X-axis, and X-axis in this case is time. And this is your Y-axis, and it doesn't say Y, but we'll add a Y here. That's your Y-axis. And in this case, Y is distance in meters. So if we wanted to find the constant of proportionality for the jet airliner, we would pick, and I'm going to go ahead and erase just so that's not in my way because I want to show you here. I'm going to zoom in. You want to pick a good point on the graph to use for your data. Now, what do I mean by a good point? You want to use a good grid point right where your grid crosses. So what do I mean by a good grid point? This right here is a grid point that I would call good because it's right where two grid points up and down and sideways cross. Okay. Now you want to pick a good grid point that your line actually crosses through. So if you're looking at this graph, this would be considered a good grid point because it's right where your line crosses through an exact grayed out grid point. Now, remember our formula is y divided by x. So if we take it, our y here is 250 and our x here is 1. Okay, so the rate would be 250 what? We got to label this. It's what? Look at your graph. Meters per second. Good. You got to look at your graph to know how to label this. Meters per second. Okay, meters per second. You have to look at your labels. Notice our other one was kilometers per minute. This one is meters per second. You always have to look at that. Look at your table or look at your graph to know how to label these, okay? Now, I want to show you this whole idea of constant of proportionality. Because it's a straight line, we know that it's going to be constant, but let's test it out. Let's take another good point, and I'll pick the point right here. And I'll say that this is 750 divided by the y, or I'm sorry, divided by the x, which is 3. Well, if you put 750 divided by 3 in your calculator, you're going to get 250, which should not surprise you because it's a straight line and we know straight lines are constant. And if we go even up one further and we go here, which is another good point because it's right where our line crosses a good grid point. If we look at the if we look at the y value here, it's 1250 divided by the x value here, which is 5. And again, when you put that in your calculator, you get 250. So the constant of proportionality for this would be 250. And it means that the jet travels at a constant speed of 250 meters per second. Okay? Are we good with that? All right. So now let's put it into practice with a story problem. This wants to know, find the cruising speed of the Cessna. Well, we already did that. And I will tell you this, and I told third hour this too. Do me a favor, and I don't know why the book does this. Mark this out. Does anybody realize or see what they did? Ms. Borden? Yes. Okay, so he should go to the front office to get him. Okay, all right, I will deliver it. Thanks. Bye. All right. The reason I want to cross that out, and I don't like the way the book does this, okay, is that this right here is the way you are going to see data given to you in math. It's going to be in a table and the X is always on top. That is just kind of a standard math practice. For some reason, when they write the information out, and I see they do it because when you do the problem, you do distance over time. So I understand why they did it, but I think it's very confusing to put it in a table that looks identical to the table above, but to put the Y on top of the X, because you are not going to see a math table with the Y on top like that. I shouldn't say you won't ever. You shouldn't, because it's not common practice. I've never seen it in a book. I've never seen it through my college days. I've never seen it on an iLearn. I've never seen the Y on top. So I just don't like that they do that. Take the information in the table as it's given to you in every math table that you should see, but you've got to know in your own mind that it's Y over X. So when you go to set up the proportion, notice our 40's on bottom here, but our 40's on top in the equation because you always do Y over X or distance over time, okay? So, but we've already figured this out. We already did this above. We figured out that our constant of proportionality was 8 because at every single step along the way, our proportion reduced to 8, okay? Now, and this is actually different information than up above, so we're actually going to refigure this. Now it gives us this cruising speed of a Boeing 747. Okay, so specifically this Boeing 747, and we want to compare who's faster, the Cessna or the Boeing. Well, the Cessna was given to us in a table, and we already found that. And so if I'm on my work paper that you guys are going to have, your line paper that you're going to turn in, you're going to have that the Cessna is 8 kilometers per minute. Okay, that's what you found. And then we're going to find the Boeing information, and we're going to write it here, and then we're going to compare them. Okay, so let's look at the Boeing. How do we do it? Well, we've got to find a good grid point where our line crosses a good grid point. And there's a couple of them to choose from, and I'll show you here which ones you can pick. The one that kind of stands out to me is right here. Okay, it's your line goes right through a good grid point, and that grid point is 60 over the x of 4, which reduces to 15. Okay. I also want to show you there's another one if you so choose to use it. There's another one here. Now, when I say a good grid point, when I draw my line over, there's nothing there. So I'm going to have to use my knowledge. I'm going to have to use my knowledge of this table and how the points work to kind of fill in some gaps. So if this is 0 right here, and this is 20 right here, what would this one be labeled? What could you label that if you needed to fill in the gaps here? Dalton? Yeah, between the 0 and the 20. Yeah, it'd be a 10. And if I needed to label between the 20 and the 40, I could label this line right here as 30. And I could label this line as 50. And I could label this line as 70. And that means what would my next line be? What would this one be? 90. So even though it's not there, I can fill in some gaps with just using some kind of basic math skills and looking at the table. And I can say that my y value here is 90 and my x value is 6. And when I divide that out, I get 15. So you can see that the constant of proportionality here, no matter where on the line I pick, as long as I pick a good point, it's going to be 15. What if I had picked, eat my hair. What if I had picked this point right, even though there's not an already established point there? That's a good point, right? It goes right through a grid crisscross. It's on my line, and I could go over to 30, and I could go down to 2. And again, it shouldn't surprise us that it does reduce to 15. So anywhere along this line, I find that proportion, it is 15. So I can come over here and I can fill in that my Boeing is 15 kilometers per minute. And now, okay, this is kind of the raw data. You've compiled all the raw data. Now you have to look and see what is the specific question asking you. You might be asked which one goes faster. In that case, your answer would be the Boeing. You might be asked which one goes slower. In that case, the answer would be the Boeing. It might be worded and it might say which one would arrive. If they both left the same airport at the same time, which one would arrive first? Well, it'd be the faster one, so it'd be the Boeing. So you have to compile your data, which is doing this work right here, finding your two constant of proportionality. Then you have to use that data to answer whatever the question might be. Okay, and in this question, it doesn't even come up with a final question. Okay. Oh, find the difference between the two paired. Nope, that's not it. I was looking to see if it actually in this gave a question. Ah, there it is. Which airline has a greater cruising speed? There we go. So which airline has a greater cruising speed, the Cessna or the Boeing? The answer would be the Boeing. Okay. If the question was which one would arrive first, if they both left the airport at the same time, the answer would be the Boeing. If it said which one was slower, it would be the what, Corbin? The Cessna. Okay, so you just have to read the question to know how to answer it after you've acquired the data. All right, so there's another way. You can have a table, you can have a graph, or you can have an equation, and that's what we're going to look at next under this try it. This is actually the easiest of all of them to find your constant proportion. Okay, here's why. You guys should be familiar with y equals mx plus b. Hopefully, I think you've done that already, right? So this is what I'm looking at right here. I'm looking at this equation. It's y equals 2.5x. Okay. When I was talking earlier about my speed, I said I wanted to know what it was when the X was 1, right? Or the bottom was 1. Okay. So if you think about what we've already talked about, we know to find the proportion, we need Y over X. And we know that the best way to compare is when X is 1, right? We've already talked about all this. So that means if I come up here to my equation and I plug a 1 in for the X, what does Y equal? 2.5. So when it's in an equation, it's actually the easiest of all to find the constant of proportionality because the constant is always right here. This is always your constant. So you don't even have to do all of the math part of it. You can just write that your constant of proportionality is 2.5. It's because that's your slope. And when we get into in the next couple of weeks, we start talking about slope and rise over run and all of that, which should be a review. Your slope is constant. That's what makes it a straight line because it constantly rises and runs at the exact same rate forever, and it never bends and goes slower or faster. Okay. All right. So again, what is it you're going to write on your actual work paper when you're doing this? Well, you're going to say we're doing the graph represents the rate at which Marlo makes origami birds for a craft fair. So we know we're comparing Marlo. The equation represents the number of birds that Josh makes. All right, so we are comparing Marlo and Josh. So on your homework paper, you're going to write the two names you're comparing, and then you're going to fill in some information. Well, the equation 2.5x represents Josh's. So Josh's constant of proportionality, we can write right away. 2.5, and it's 2.5 what? Let's label it. 2.5 what? Miles per hour? Pounds per minute? Pounds per ounce? Dollars per ounce? What is this? Birds per minute. Yeah, you always have to look at your information. It's birds per minute. So Josh can make 2.5 birds per minute. Okay, always look to your graph or your story problem to know how you're labeling this. All right, now we got to look to Marlo. Marlo is given to us in a graph, and we know how to find that constant of proportionality from a graph. We're going to find a good point. This looks like a good point to me. We're going to put the Y over the X. And that reduces to 1/5. And since I'm comparing it to another number with it that has a decimal, I'm going to go ahead and convert this to a decimal. And 1 divided by 5 equals 0.2. Oh, me too. So Marlo, based on the graph, Marlo can make 0.2 birds per minute. Okay. And if we want to confirm that, and you don't have to do this each time, I'm just showing you that it doesn't really matter. What if I had picked this point right here? It's a good point. And I had come across and I'd have had 8 over 40, which reduces to 1/5, which reduces to 0.2. So even if I had picked a different point, I still would have gotten that same answer. All right, so what does the question ask? Remember, you always have to go to your question and ask what is it that's asking? Who makes birds at a faster rate? Okay, so we want to know the answer is who makes birds at a faster rate? What's my answer? Josh. What if it had said who makes birds at a slower? Then your answer would have been Marlo. So you just have to watch what your question is. It's not always going to be who's the fastest. So just be careful you don't get one wrong just because you simply didn't read the question right. Okay. All right. Let's see. Let's do one more and then, nope, 2 more. Sorry. 2 more. But we don't have any homework tonight. So make it through notes and then you guys are done. Okay. No homework tonight. When you come into class tomorrow, there's a 2.5 Math Excel that will be putting all of this into practice. You'll be given data in a graph, you'll be given data in a table, or you'll be given data in an equation. You're going to have to convert them all like we're doing, right, into this comparable. And then you're going to answer the question, who's faster, who's slower, who's quicker, who's going to be there soonest, who's whatever. Okay, who's the better deal, whatever it might be. All right, so let's look at this one. The graph on the right represents the rate at which Daniel earns points in a video game. The rate at which Brianna earns points in a game is represented by the equation y equals 2x, where y is the number of points and x is the time in minutes. At these rates, who will earn 100 points first? So before I get started on your work paper that you're going to be turning in, you're going to write down who you're comparing. You're comparing Daniel and you're comparing Brianna. Okay, those are the two things you're comparing. And in order to make that comparison, you are going to have to come up with a constant of proportionality for both of them. And you're going to write that out. And what do we know about Brianna's? Brianna's is the easiest because Brianna's is right here. Y equals 2x. What's our constant there for Brianna? Somebody tell me. Who haven't I heard from? Maylee, what is Brianna's constant? Yeah, it's that from the equation. It's that 2, and it's 2 what? 2, how would we label this? Brady? Points per minute. Where did I get that? Well, we're comparing points earned, and the time is in minutes. So Brianna earns 2 points per minute. Now we need to look at Daniel. Daniel's is in a graph. So we're going to use the graph to set up a fraction. And you've got multiple places you can pick here. I'm going to pick this one because, well, it's going to be over 1, so I won't even have to reduce it. But your y is 3 and your x is 1. So it just reduces to 3. If I had gotten really wild and crazy and come up here and done this one, it would have been 15 over 5. And it still would have reduced to 3. So it is a constant number here. So Daniel, I can fill in, is 3 points per minute. And now that I've compiled the raw data, I've got all my information that I need. Now I'm going to go back to the question. And the question was, at these rates, who will earn 100 points first? So what's the answer? Eli, what's the answer? Yeah, Daniel's going to earn 100 points first because he's earning them at a faster rate. Okay. All right, one more and then we're done. So this is not a speed. So this is a good one to kind of end it in. This is very much like the one we started with our bushel of apples. All right. So it says the graph represents the cost per ounce of granola cereal. A 15-ounce box of raisin cereal costs $3.90. So we're comparing a couple of different things. We've got a 16-ounce box of raisin cereal is $3.90. And then the information about the granola cereal is over here. And it's given to us in a table. So we've got something, or we've got some bit of information just given to us, kind of raw data. We've got some in a table. We're going to pull all that information and we're going to compare it just like we've been doing. So again, on your paper, what are you going to compare? You've got your raisin cereal that we're comparing. And you've got your granola cereal that we're comparing. Okay, those are the two things you're going to write out on your paper. And you are going to tally up both of them. You're going to find this constant of proportionality. All right, for the raisin cereal, what do we know about the raisin cereal? We know that it costs $3.90 for 15 ounces, right? So we need to know what it costs per 1 ounce because that's how we can compare them, is get them both down to 1. This is just like our bushel one. So if you take $3.90 and divide it by 15, we get 0.26. So that means that the raisin cereal costs, okay, for our final answer here, 0.26 what? Dollars per, is it ounce? All right. So we know raisin cereal is $0.26 per ounce. Now we need to go over here to the granola. Now, notice the points that they give us in purple are not really good points. This one is not a good point. This one isn't a good point, and this one isn't because they're not right on a graph intersection. So I'm going to go up my line until I find a good one. And my first good one is actually not till way up here. That's a good point because it's right on the intersection. Okay, but again, I've got to use some common sense here to fill in the data. And that's a 1. If this is a 1, a 2, each box, a 3, a 4, what would I label this top line? Anybody? A 5. Good. So when I go across, my Y value is 5 and my X value is 20. And when I reduce that, I get 1/4, which equals 0.25. Okay, everybody agree with that? All right, so I'm going to come back down here to my little thing I'm compiling. And I did that 5/20 equals 1/4, which equals in dollars 0.25 per ounce. All right, so I've compiled my raw data. Now I need to go back to my question and see what they're actually asking. Are they asking which one costs more, which one costs less? Where should I shop if I want to spend the least amount of money? Always look to your question. All right, here it says, which cereal costs more? Okay, there it is. It's more per ounce. So what's my answer? Raisin. So I would select raisin as my answer if it was in a drop-down menu. So 2 things I want to kind of drive home, and I know I've said them a lot. One is do this on your paper. I need to see this for every question that you're comparing 2 things, whether it's 2 people, 2 planes, 2 cars, 2 cereals, 2 whatever. Write it out. Show how you get the rate for each one. Then once you have it, always go back to the question of the problem, because it's not always going to be who is more. Sometimes it's going to be who's less, who's more, who's faster, who's slower. Who are you going to save money with? Who are you going to take more time with? You got to really read that question. The other thing, real quick, I want everybody to pause, putting stuff up. I want all eyes up here. Okay. Tomorrow I won't be here. The 2.5 Math Excel is already on Canvas. I'll make sure I get it published. Everybody is going to have a piece of paper, either from this stack over here or that stack over there, or your own, just not spiral bound. Please put your name and put 2-5 Math Excel. And I believe there's 6 questions. So you're going to want to number it, number 1. And then I need to see this right here. I need to see what you're comparing on number 1. Are you comparing 2 people, 2 places, 2 whatever? Show me your 2 proportions and then use that information to answer the question. Okay. All right. And then I will be here on Thursday and we'll do any quick questions that you might have from your homework. If you have your work from Khan Academies that was due today, please put that in the tray. And for those of you at home, if you have any questions, please shoot me an email.